Hey everyone, welcome back to this channel. Today we are diving deep into one of the most realistic and widely used volatility models in finance, the GARCH 11 model. This model is used in banks, VAR engines, hedge funds, trading FX desk, in algo trading strategies, derivative pricings. So in this video, what we are going to do, we are going to understand how GARCH 11 model works, why we need seed variance, why we use 60-day correlation window, and how we can calculate this portfolio VAR. So, if you know, if you are following my series, you would know that I am just trying to implement all kinds of risk models on this particular portfolio consisting of dollar INR and dollar JPY of 1 year window period where my portfolio consists of weightage 60% dollar INR and 40% dollar JPY. Okay. And my portfolio total valuation is 1 million US dollar. Okay. So let's try to implement here. So let's first understand why we need GARCH. So what happens in real markets? So in real markets, there are volatility clusters. There are days where there is high volume, which are followed by again high volume days. Then there are low period volume periods as well, which are relatively calm, and there are little bit of shocks which do not disappear instantly, and there is a volatility throughout the period as well. So simple moving averages cannot capture this, and even EWMA reacts too quickly sometimes. So what GARCH brings out? GARCH solves this by combining yesterday's shock and yesterday's volatility and a long-term base volatility into a dynamic and realistic volatility forecast. So let me just show you this formula. So this is the how we calculate GARCH variance. Okay. So here, so it consists of three parameters: omega, which is long-term base volatility. Then there is alpha, which is a short-term shock sensitivity, and there is beta, which is volatility persistence. So if I want to give you intuition, think of like think of volatility like a hitting water. So when you just turn on the flame, the water starts to boil down. Okay, so that is similar to alpha. When you turn off the flame, the water is still hot. Okay, that is beta, which is persistent. Okay, and there is a omega before just turning on the flame, whatever the water's temperature was, it was omega. So it's a very basic intuition that you can know. Now we are going to follow 7 steps, just like we did in previous video of EWMA, and we are going to just calculate these parameters here. So we are going to calculate VAR at 95%. Expected shortfall as also at 95%. Okay. So first find out the change in um, daily change in both currencies. So it is very simple. Current day's rate minus previous day's rate divided by previous day's rate. We can just drag for all the days which are down there, and we just copy paste this formula for dollar JPY as well. Now we want to calculate variance. Okay. So here it is a there is change. So we need to provide a seed variance. Why we need to just provide the seed variance? Because When we start calculating GARCH variance on day one, we have few problems that we don't have a yesterday's variance yet, but formula needs it. So for how much tenure we should use a sample variance for to it. So normally what banks do that they follow take around the days 30 to 60 days variance for a longer period of durations, and this can be around 250 days, 500 days, whatever you want to take. For this portfolio, I am going to take a variance of 20 days. Okay, so for 20s, I'm going to calculate. So I'm going to take, it will be like total returns will be of 20 days. So variance will be a so that's how we just put initial sample variance for dollar INR and dollar JPY. Now we are going to calculate GARCH for the next day. So we are going to use this simple formula. It, it's tell us that we need to add omega plus alpha times previous day returns square, which is this, multiply by again this, plus beta times previous day's variance. You should know that we have taken omega, alpha, and beta. So these are the we can calculate these values also. We can calibrate this model as well. But for FX purpose, we have taken these assume these values. Okay, so we can now fix these parameters. And we can also calculate standard deviation per route. We can drag this formula. Now we are going to find out the correlation for 60 days. So first question comes, why do we need a 60-day correlation window? So let's answer another important question. If we are using volatility, okay, just let me put it this way. Why we need it? So correlation changes much slower than volatility. Volatility reacts quickly to shocks, while correlation moves only when there is a economic regime shift, monetary policy changes, crisis periods begin, or some kind of structural effects relationship break. So if we take around 20 days correlation, so it becomes too noisy. And if we take longer, it is going to become too stale. So 60 day period window will bring both stability plus responsiveness. So that's why it is being used in Basel and FRTB documentation as well. Many banks use reference ruling windows like 60 day, 90 days. Okay, so it is better assumption for us. Okay, so we are going to take a 60-day correlation. So if we going look at the first 20 for 20th day, it does not have 60 days. So we are going to neglect it. Count. So if it is less than 60, we are going, this function is going to throw a error. Otherwise, if it is greater than 60, then we are going to calculate the correlation between two these values. We are going to fix this parameter here. So after 60 days, it starts to calculate. Now we are going to calculate the portfolio variance. So it is can be calculated using this formula right here. Nice. Yeah, just write it down like proof multiply by dollar INR variance plus 2 into weight is 1 multiply weight is 2 multiply by, so we just now calculate correlation not covariance, so we are going to multiply variance into of dollar INR, then variance of dollar JPY, then we are going to multiply with it with correlation. Since correlation has NA, so we are going to get a value NA. So that's how we can calculate portfolio variance. It is going to give NA. After 60 days, it will start giving us values. So you can see here, start giving us portfolio variance. Then we can calculate standard deviation here. And VAR 95% can be calculated using this formula. This similar formula we have used in DWMA as well. So we can calculate Z alpha. So G score for 95% is this 1.64 multiplied by portfolio variant standard deviation multiplied by portfolio value which is 1 million. So we can fix G score value and portfolio value. We will get variation VAR. Sorry. of 95% confidence interval, we again can this drag this formula here. So it will start giving us values from day 60 onwards. Start getting values. I should put a negative here. So wasn't putting a negative sign here. So now we are going to calculate the expected shortfall. Please note that this formula doesn't have portfolio value multiplication. We need to include that as well. So exponential minus 0.5 multiplied by g value in multiplied by g value. Uh, we need to fix these values as well. Divided by 1 minus alpha, which is confidence interval. We need to fix this as well. Multiply by square root of 2 multiply by pi multiply by portfolio standard deviation multiply by the portfolio value. We need to fix this as well. We are going to get 10 till 60. After that, we are going to get the values. We should also put a minus here. So if you can see here that expected shortfall is greater than the value at risk at 95% VAR. Okay, and it keeps changing with the volatility, and we can just check at what at 99% is it should be approximately 7,000 something. Okay, so yeah, sometimes 7, sometimes 8. Oh, in fact, it went to till 10,000 as well at 99% is. So through this, we can calculate expected shortfall. Okay, using GARCH approach. So how to calculate estimated shortfall? We are going to just see a small comparison between EWMA and GARCH phenomenon. So in EWA, we are going to have a fixed lambda decay parameter, and in GARCH, we are going to have a flexible alpha and beta, so which allow us to experiment. And EWMA does not follow mean reversion, while GARCH follows mean reversion. Okay, and basically simple differences. So shock versus persistent. So again, same thing. It has only one parameter, whereas in GARCH have two parameters, alpha and beta. Okay, so it can EWMA can little bit follow real time volatility, but GARCH model can follow real time volatility very quickly. So this methodology is same, just that we are using some different way of calculating variance in GARCH. So basically, GARCH is essentially a updated version of EWMA. Okay. So where it is being used? So it is being used in FX and equity volatility forecast, derivative pricing, banking risk engines, portfolio VAR, algo trading, portfolio optimization, hedge fund strategy. Okay, so in this video, what we did, we uh, just calculated VAR using GARCH, and we also assumed seed variance. We have taken a 60-day correlation window, and we used all this to calculate the VAR. Okay, so in next video we are going to implement solar based MLE. We are going to just calibrate these values alpha, beta, and omega, and also we are going to do the back testing of this model. Okay, so stay connected and follow this series. Thank you.